Sub-kiloton nuclear blasts, less than 1 kiloton of TNT. Sub-kiloton nuclear blasts are the lowest tier of nuclear explosions, producing energy under the equivalent of 1 kiloton of TNT. Despite their relatively small yield, they are still capable of catastrophic local effects. These weapons are typically developed for tactical military operations, sometimes referred to as mini-nukes. Their main advantage is limited collateral damage compared to larger strategic warheads. For instance, a 0.3 kiloton explosion would obliterate structures within a few hundred meters, create a fireball over 100 meters in diameter, and cause third-degree burns out to 500 meters. Radiation exposure in the immediate blast zone would be lethal. While they wouldn't destroy a whole city, such weapons are effective against hardened underground targets or compact military bases. North Korea is suspected of testing sub-kiloton weapons in its early nuclear program. Despite their small size, these devices still carry immense geopolitical consequences due to their radioactive fallout and breach of nuclear use norms. Low-yield tactical nukes, 1 to 10 kilotons. Low-yield tactical nuclear weapons produce blasts between 1 and 10 kilotons, roughly equivalent to the bomb dropped on Hiroshima, which had a yield of about 15 kilotons. These bombs are designed for battlefield use rather than strategic deterrence. A 5 kiloton detonation, for example, would level most structures within a 1 kilometer radius, cause third-degree burns up to 1.5 kilometers away, and deliver lethal radiation exposure to anyone caught near ground zero. Tactical nukes can be launched from artillery shells, cruise missiles, or short-range ballistic missiles. The concern with these weapons lies in their strategic ambiguity. They blur the line between conventional and nuclear warfare. Countries like Russia and the US maintain tactical nuclear arsenals to deter or respond to limited nuclear exchanges, but the use of even one such weapon would drastically escalate any conflict. Medium-yield strategic nukes, 10 to 100 kilotons. Strategic nuclear weapons in the medium-yield category range from 10 to 100 kilotons and represent a significant step up in destructive power. A 50 kiloton bomb, for instance, would cause near-total destruction within a 2-kilometer radius, generate a fireball wider than a city block, and ignite fires and radiation sickness over several square kilometers. Fallout from such a blast could contaminate entire regions, depending on wind patterns. These weapons are often mounted on intercontinental ballistic missiles, ICBMs, or airdropped from bombers. The bomb dropped on Nagasaki, known as Fat Man, had a yield of around 21 kilotons, instantly killing over 40,000 people. Medium-yield nukes are the backbone of many nuclear powers' deterrent strategies. They are powerful enough to destroy major military or industrial centers, but small enough to allow for multiple warheads per missile, known as MIRVs, multiple independently targetable re-entry vehicles. High-yield thermonuclear bombs, 100 kilotons to 1 megaton. Once a nuclear weapon exceeds 100 kilotons, we enter the domain of high-yield thermonuclear devices. These bombs typically use a two-stage process, fission to trigger fusion, to release far greater energy than pure fission bombs. A 1 megaton explosion creates a fireball over 2 kilometers wide, can incinerate everything within a 5-kilometer radius, and generate blast waves that shatter buildings tens of kilometers away. Thermal radiation can cause third-degree burns up to 15 kilometers out, and fallout can spread globally. These bombs are designed for mass destruction, capable of wiping out entire metropolitan areas like San Francisco or Berlin. The US B-83 bomb, one of the most powerful in the US stockpile, can be configured for yields up to 1.2 megatons. High-yield bombs are rarely used in modern military planning due to overkill and collateral damage, but they remain in arsenals as strategic deterrents. Multi-megaton bombs, 1 to 10 megatons. Bombs in the 1 to 10 megaton range are capable of unprecedented destruction. A 5 megaton weapon can produce a fireball 4 kilometers wide, vaporizing everything in that zone. The blast wave from such a weapon can flatten buildings up to 15 kilometers from the epicenter. The thermal flash is so intense that people up to 30 kilometers away could suffer severe burns. In real terms, a single 10 megaton explosion could destroy a city like New York in seconds. During the Cold War, both the US and USSR developed many bombs in this range. such as the American Ivy Mike test, 10.4 megatons in 1952, which obliterated an entire Pacific atoll. The fallout from such weapons can encircle the planet, entering the jet stream and irradiating populations far from ground zero. These weapons were deemed excessively destructive even by Cold War standards, leading to their gradual retirement or redesign. Super thermonuclear bombs, 10 to 50 megatons. Super thermonuclear bombs, with yields between 10 and 50 megatons, represent the upper limit of tested human-made explosions. The best-known example is the Soviet Tsar Bomba, detonated in 1961. With an estimated yield of 50 megatons, it remains the most powerful nuclear device ever detonated. The explosion created a fireball nearly 8 kilometers wide and a mushroom cloud that reached 60 kilometers into the atmosphere. The shockwave circled the Earth 3 times and shattered windows over 900 kilometers away. Had the full design been used, intended for 100 megatons, the destruction would have been even more apocalyptic. These weapons are often considered impractical for modern warfare due to their size, delivery difficulty, and overkill factor. Yet they serve as terrifying reminders of the heights of Cold War brinkmanship and the sheer scale of devastation possible with nuclear technology. Hypothetical gigaton-class devices, 1,000 megatons or more. Though never built or tested, hypothetical gigaton-class nuclear weapons have been discussed in theoretical physics and Cold War-era think tanks. These would be 1,000 times more powerful than the largest bombs ever detonated. A 1 gigaton bomb would have a fireball spanning over 20 kilometers and could level everything within a 50 to 100 kilometer radius. Thermal radiation from such a blast could burn skin hundreds of kilometers away. The global effects would be catastrophic. Immediate death tolls in the millions, radioactive fallout blanketing continents, and atmospheric disturbances triggering climate collapse. These hypothetical weapons would be capable of planetary-scale destruction, affecting agriculture, weather, and the ozone layer. Though no nation is known to possess such devices, they have been considered in doomsday scenarios, like the Soviet Dead Hand system or speculative asteroid defense plans. Fortunately, the physical constraints and moral considerations make such weapons unlikely to ever be realized. Salted bombs, radiation-maximized weapons. A salted bomb is a theoretical type of nuclear weapon designed specifically to maximize radioactive fallout instead of explosive power. By surrounding a thermonuclear device with elements like cobalt or gold, the detonation would create long-lasting radioactive isotopes that render large areas uninhabitable for decades or even centuries. A cobalt-60 salted bomb could theoretically turn thousands of square kilometers into a nuclear desert. While no salted bomb has ever been tested, they are often discussed as doomsday weapons meant for total environmental destruction. Unlike conventional nukes that rely on immediate blast effects, these are strategic weapons of delayed annihilation, capable of poisoning the atmosphere, water supply, and soil on a massive scale. They are the ultimate terror weapon, ensuring mutual destruction even if the attacking side is annihilated first. Nuclear tsunami bombs, seismic or underwater use. Another specialized application of nuclear weapons is using them underwater to create massive tsunamis or seismic effects. The idea is that a high-yield underwater nuclear detonation near a coastline could generate an artificial tsunami, flooding cities, and causing massive casualties. The Soviet Union experimented with this concept in the 1960s, most notably with the development of the Status 6 Poseidon underwater nuclear drone, reportedly carrying a 2-megaton warhead. The weapon is allegedly designed to detonate near coastal cities, causing radioactive tsunamis and long-term contamination. While no nuclear tsunami bomb has ever been used in warfare, such technology represents a terrifying blend of nuclear and environmental warfare. Detonating nuclear devices underwater also creates radioactive plumes that persist for decades in marine ecosystems, damaging both biodiversity and human populations dependent on oceans.